Okay, class. So the previous lesson, 6.4a, dealt with the circumference of a circle. But now we are going to dive into calculating the area of a circle. Um, so we're going to give you the formula. It's just another version where you use pi and you use the radius. One thing that we have to note about the area of a circle is that it never uses the diameter. Okay, so there are a lot of helpful videos that you could watch. I'll be posting some videos to help you with this as well, in addition to this video lesson. But um, there are many things that we could watch to help improve our understanding of the area of a circle. But I'm going to go ahead and give you the formula right now. So let's skip all the way to number 6, and it just asks us to estimate the area. Now, we do know that if we wanted to estimate, there are many routes, right? We could say, hey, what if I just calculate the square around the entire circle, calculate that area, and then give or take subtract these kind of like outer shavings. If I were to do that, that would be one route. Another route would be to just calculate all these total full squares that you see. That's a little bit time intensive and it's a little tedious, but you can actually literally count all the boxes because every box is considered one square unit, right? So you just count all the total boxes. But just I would say the easiest route would just to calculate the square and then subtract four of these little corners. So I'm going to go ahead and do that. We know that the height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm assuming this is also 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so if it was a 12 by 12, it would be 144. But now let's calculate one of these little corners that is missing. I'm going to calculate with the full squares first. 1, 2, 3. And then I also know that there's like these 3 over here that are almost a square. So that's kind of like 6. And then there's like these little bits and pieces. Let's just calculate that as 6. So if each of these are 6, then I then have to subtract 24 from 144, which gives us about 120. Okay, again, this is a very, very, very approximate, but that's how we would calculate the area of a circle. Okay, now let's just give you the formula. I'll be writing this formula down many times, so hopefully you get used to it. But the area of a circle is always pi times the radius squared. So let's see if our estimation above was accurate. So all you have to do, class, to find the area is you take pi, which we know is 3.14, and you multiply it by the radius, and you multiply it by the radius again. This is why we call it pi r squared. Remember, by definition, the radius is the distance from the center to the edge of a circle. So we kind of knew that this was 12. So it's like the diameter is 12. So I already know that the radius is 1, 2, 3, 4, 5, 6. Yep, 6. Okay. So 3.14, according to the formula, 3.14 times 6 would give us the area. Okay. So now I'm going to use my calculator and I'm going to calculate what that is. Well, 6 times 6, class, we know that that's 36. 36 times 3.14 is 113.04. So I'm a little disappointed that our estimated area was not entirely accurate enough. It's probably because I overestimated something, and the actual area is 113.04. So this is a little bit off. Okay, so I already did that here. I apologize. I'll write it one more time. It's 3.14 times 6 times 6, which equals 113.04 units squared. Calculate the area for 7 to nearest. Oh, okay. So the first one wanted me to use pi. The second one wants me to use the approximation. Remember, pi is the actual. The approximation is the decimal version. So this is the approximation. And instead of writing 3.14, I should have just left it as pi. So it's actually 36 pi. If you leave it in pi class, that's considered the exact form. And then the approximation is considered the decimal form. Okay, so now let's calculate. And like I said earlier, you always need to know the radius. For area, we never care about, or we never use the diameter in a formula. Okay, so the radius here is 3.5 feet. The area in terms of pi is going to be pi times r, which means it's just pi times 3.5 times 3.5. And I know what 3.5 times 3.5 is. That's 12.25 pi, and that's in feet. Now, the only thing left we have to do is we have to then plug in 3.14 4 pi to get this piece. So 12.25 times 3.14. Now, I do not know that, so I'm going to go ahead and go 12.25 times 3.14, and I get 38.465. I would round to the nearest tenth, so that is 38.5 feet squared. Now notice again, you're starting to see that this is an approximation. When you use the decimal version of pi, 3.14, we are approximating. Now it's decently close, but it still is an approximation. Okay, so the second question does not give us the radius. The second question gives us the diameter. Okay, so we don't want the diameter. So if the diameter is 2.4, you know that the radius is 1.2. It's half the diameter. The area is going to equal pi times r times r. That's always the area of a circle. So it's going to be pi times 1.2 times 1.2. And yes, I do know what 1.2 times 1.2 is. That's 1.44 pi. So then the second portion is all we have to do is plug in pi. So we get 1.44 times 3.14, and that's where you use the calculator. And to round to the nearest tenth, I'm getting 4.5 inches squared. Okay, let's try one more. Now, again, are we starting to see that if this question itself gives you the radius, that's actually really, really easy, because all you have to do is plug it into the formula. R equals 5 miles. Area equals pi times r times r. Literally multiply the r by itself. So it's called r squared. So area is equal to pi times 25. Now, we always want to put the number in front of pi, so we call it 25 pi. It's kind of like a coefficient. 25 pi miles. And then on the other side, they're saying, okay, well, what is that actually, like approximately, if we don't use the pi? Well, then we just say 25 times 3.14. I believe that's 78.5. Yes, it is. Over time, class, when you do this more often, you'll start to see the patterns and you'll start to almost memorize the numbers. Okay? Good. So let's take a break here.